Good morning. Good morning to one and all. Today I will brief about the Moore circle. I myself, Akash Mahanti from School of Mechanical Engineering, VIT University, Vellore. So Moore circle. Moore circle is named after Christian Ottomer. Is a two-dimensional graphical representation of the stress state of stress at a point. The abscissa sigma n and the ordinate tau n of each point on the circle are the normal stresses, and the stress components are relatively acting on a particular chord plane with a vector n with components n1, n2 and n3. In other words, the circumference of a circle is the locus point that represents the state of stress on individual plane at that orientation. Sign conventions for Moore circle. To draw the Moore circle, we have to be very careful and should be aware of the sign conventions, and the following sign conventions should be followed. The tensile stress, if positive, are to the right side from the origin, that is positive x-axis. Compressive stress, if negative, are taken to be left side from the origin, that is towards the negative y-axis. The clockwise shear stress are plotted upward, that means in the direction of positive y-axis, and the counterclockwise shear stress are plotted in the downward direction from the origin, that is towards the negative y-axis. So to draw the Moore circle, in order to draw the Moore circle on a Cartesian coordinate system, the x-axis and y-axis are identified as sigma axis and tau axis respectively. First two points of the circle to be plotted as point 1, that is first point is coordinate is sigma x and tau x, and the point 2 is sigma y tau xy. The line connecting these 2 points is the diameter of the circle. Knowing this, the circle can now be drawn. The center of the circle is located where the diameter intersects the sigma axis. It is also average normal stress sigma average. The average normal stress can be read from the coordinate system if it was drawn to the scale, or it can be calculated by using formulas. So this the Moore circle will looks like this. This is your y-axis and this is your x-axis. From the origin we have to go to right side if it is sigma x is plus. So to draw this circle from this center, we have to go towards right side if sigma x is positive. Then from here we have to take the tau xy. Similarly, from the origin we have to go to left side, then we have to go to the bottom. Then we will get 2 points, and these 2 points if will join together, it will pass through the center of the Moore circle. The Moore circle will looks like this. One point when it is crossing this point, it is called sigma 1. The other side which is crossing to the x-axis is sigma 2. The vertical distance, highest distance, is called sigma max, and the distance from the origin to that point of circle is sigma average. And at this point the shearest vertical height is 0. As you keep on moving over the circle, the vertical height which is representing the shear stress is maximum. At this point it is minimum. So this is one pictorial representation of the typical Moore circle, where sigma x is in positive direction, sigma y is in negative direction, and in the vertical plane the shear stress is acting downward, so that is towards tending to rotate the clock in clockwise direction. So this is some important points you can remember. The maximum and minimum shear stress will act 45 degree to the principal plane. If we will see, look at this one, this is one principal plane, this is another principal plane, these two principal planes, and this is this point, this is called sigma x and tau xy, and this is sigma y tau xy. In real cases, in in the Mohr circle the sigma x and sigma y are 180 degree apart, whereas in the real cases it is 90 degree. Here this plane, this at this point, this the distance from origin to at this point is called sigma 1 or major principal stress, and this point and vertical topmost point is called shear stress is maximum. So in between this maximum shear stress principal stress, the angle is 45 degree, is 90 degree. So in actual case it will be half of that. The angle of an inclined plane we will measure from the vertical. You have to remember that angle of inclined plane we will measure from the vertical plane in counterclockwise direction is positive. So this is the Mohr circle. This is maximum at shear stress is maximum. This is principal sigma 1, sigma 2, and this is one point sigma x and tau xy, and this is sigma y and counter elementary shear stress. So it is minus tau xy. So this is typical representation sigma x, sigma y principal stresses. So this is one typical problem where there is a normal stress sigma x is acting on a body of magnitude 4000 MPa and sigma y 3000 MPa, and the shear stress in vertical plane is 1000 MPa tending to rotate in anticlockwise direction above this point, and in the horizontal plane 1000 MPa is acting in the clockwise direction. So how to represent these stresses in a graph? This is your x-axis sigma x and this is sigma y. So this is a principal plane, the plane at which the stresses major principal plane, major principal stress has an angle theta degree. So from this vertical plane it is theta degree. The angle at which the sigma 1 is acting. From this one it will go 45 degree in anticlockwise manner. You will get the plane of maximum shear. Again from this line if you go 90 degree, you will get another plane sigma 1 and sigma 2. Sigma 1 and sigma 2 are 90 degree apart. Again from sigma 2 plane if you go 45 degree anticlockwise, you will get Q max and Q min. So this Q max plane, this is one plane and this another, so they are 90 degree. Similarly sigma 1, sigma 2 are at angle 45 plus 45, 90 degree. This is your x-axis and this y-axis, for sigma x is acting and sigma y is acting, both are 90 degree. So to represent this one, this is your vertical line, this is your plane at which sigma major principal plane and stress is acting at angle theta. So from this one you have to go for theta degree, then from there you will the sigma 1 is acting. From this 90 degree it will go, then sigma 2 is acting, and this is the angle, this line is parallel, so this is Q max. Q max is acting at an angle 45 degree to the plane of major principal plane. So now we will know how to draw a Mohr circle. To draw a Mohr circle, first we have to draw the question figure, or in the question figure the sigma x and sigma y are acting, and there is no shear stress in vertical and horizontal plane, there is inclined plane, and the inclined plane sigma n is acting and tau is acting. The sigma n is at angle theta degree to the direction of the application of the sigma x. So to do this one, this is your vertical plane and this is your horizontal plane. So first point is to locate the vertical plane as well as the horizontal plane. So the coordinate of the vertical plane, what are the stresses are acting in the vertical plane, we have to see. So in vertical plane sigma x is acting and tau xy is acting of magnitude 0. So we have to represent the vertical plane. So from this origin you have to go sigma x value here, then from at this point you have to mark the tau value. So here tau is 0, so here you have to put first point, then you have to mark the second point, which this is your horizontal plane. So this horizontal plane, two stresses are acting, sigma y and tau xy of magnitude 0. So this point is your horizontal plane, so sigma y, and we cannot move up and down because tau is 0. So this is one horizontal plane, this is one vertical plane. Here horizontal plane, vertical plane 90 degrees, so here it is 80 degree. So we have to join this one, you have to mark the center, this will take as a radius, we will make one circle, this is called Mohr circle. So from this vertical plane, the inclined plane is at angle theta degree and anti-clockwise manner. So this is your plane, vertical plane. From this it will go to theta degree double, then we will get one point. This is called oblique plane. So from the oblique plane, you will measure the horizontal, the distance along the x-axis. This magnitude is called sigma n, and the vertical distance is called shear stress tau. The shear stress in the oblique plane. And the point, if you join from here to here, this will give you the resultant stress. This is more one point is added here in this direct stress with simple shear. So here the shear stresses are acting in the vertical plane and horizontal plane. So in this type of cases, how to draw the Morse circle? The basic fundamental principle is that all the tensile stresses is taken along x-axis and all the shear stresses is taken along y-axis. If the stresses, shear stress try to rotate the block in clockwise manner, then you have to go toward the positive y-axis. If the shear stress in the plane try to rotate the block in anti-clockwise manner, you have to go to the downside. So let us mark the vertical, this is the vertical plane of magnitude sigma x and tau xy. So from origin you have to go this distance sigma x, and again the vertical plane carries a shear stress which try to tending to rotate the block in anti-clockwise manner. So you have to mark the same magnitude with appropriate scale in downward direction. So we will get one point. This point is vertical plane. Again we will see a horizontal plane. This horizontal plane, two stresses are acting, one is sigma y and another is shear stress tau xy. So from here we will go sigma y distance. From at this point we will go the tau xy. Tau xy, the sign convention is try to rotate the block in clockwise manner. So we have to go from here to here in upward direction. So this is this point will achieve this color horizontal plane. Then we will join these 2 points. It will pass, it will cross the x-axis at a certain point, that will be the center of the Morse circle. And by taking center of the Morse circle and vertical plane as radius, we will draw one circle, that is called Morse circle. This Morse circle will intersect the x-axis at one point, and the other point, 2 points it will intersect. This is first point. The distance is maximum. So this is a major principal plane. The stress which is acting here is major principal stress. Similarly, that point which is crossing here, minor principal plane, and this magnitude of the stress is sigma 2. So now this is our vertical plane. So vertical plane, the inclined plane is at angle theta degree. So this is your vertical plane. From here you will go to theta degree, and if you draw one line, it will intersect the Morse circle at a certain point. This point is called oblique plane. So the oblique plane has two stress, one is normal stress, one is parallel stress. So the vertical distance which is measured along the parallel to the x-axis is sigma n. And the vertical distance which is measured parallel to y-axis, which is shear stress, equals sigma tau. Then to determine the resultant stress, just you have to measure the distance from here to oblique plane. Measure, it will give you sigma. If you put this one in the formula, sigma n square plus tau square root over sigma r. The angle between tau and sigma r is phi. So this is the. So we'll see. I have to draw. This is a rectangular body. We will revise again. And in the vertical plane, one normal stress is acting sigma x. Then in horizontal plane, one stress is acting. This is sigma y. And in vertical plane, one shear stress is acting, and in horizontal plane, one shear stress is acting of magnitude tau xy. Now one inclined plane is at angle theta degree from the vertical plane, measured in anti-clockwise direction. To draw the Morse circle, let us draw the y-axis, then draw the x-axis. Then you draw the sigma x. In this vertical plane carries two stresses, sigma x and tau xy. So you draw sigma x, then this try to rotate in anti-clockwise manner, so this is tau xy. After that you have to draw the sigma y, this is in x-axis, and then tau xy. Now you have to join these two lines which is passing through the center. So if you draw a circle passing through, this is called Morse circle. This Morse circle, this is Morse circle, and this is your vertical plane. From the vertical plane, the oblique plane is at angle theta degree. So if we draw angle 2 theta degree here, and if we draw one line, it will intersect the Mohr circle at a point. That point is called the oblique plane, and the distance from here to here is called sigma r. The distance from here is called sigma r, and the angle between horizontal plane and here is called phi. And the distance horizontal is from here to here, from yx to here, is sigma n, and this is the important observation. Sigma x and sigma y are 90 degree apart, but in real practice, but in Mohr circle they are 180 degree apart. So all the angles measured from the Mohr circle should be divided by 2 except for the oblique angle. The two end points of the horizontal diameter sigma 1 and sigma 2. The point over sigma 1 represents maximum normal stress, and the other point is for minimum. So this is the end of our. So if you have any queries or any doubt, you can mail me. Thank you.